Hello and welcome to Ott Math. In this edition of Ott Math, we're going to talk about dilations. It's the last topic of our transformations. So first, again, we talked about reflections and translations. Then we discussed rotations, and now we're on dilations. So remember, dilations is not an isometry, which means it doesn't keep its same size. All right. So let's start first by talking about stretches, and then just to give you an entree into dilations. How stretches work, very similar to how we're going to work with dilations. But stretches, we're going to stretch in just one dimension, whereas dilation is in, say, all dimensions on a plane. All right, so a stretch is like a dilation, but in only one, but in only one dimension, either vertically or horizontally. And figures are stretched by a scale factor, just like they are with dilations. Figures are symmetric about the x and y axis. Only require that we multiply the coordinates by a given scale factor, and that's what we're going to do today. So when we write a rule for a stretch, similar to the rules that we've been writing, in parentheses x comma y with the arrow, and then we write in the scale factor times x, and then comma y. And in this case, I give an example where we go x, y, and the scale factor for x only is going to be 2. All right, so we're going to take an image here, -3, 0. So it's a trapezoid, -1, 2, 1, 2, and 3, 0. And we're going to stretch the image, the trapezoid, by a scale factor of 2. So we're going to stretch it horizontally. So the values for x will be multiplied by 2, and the values for y are going to stay the same. All right, so this is what ends up happening as we stretch the values horizontally. See, the vertical values stay the same, the y values stay the same, the x values are going to change. All right, so first thing we want to talk about, understand the concept and vocabulary of dilations. And this again is 16.4. So dilation, this is the fourth transformation, the shrinking or expanding of a figure by a given scale factor. Dilation means to make larger, but in math we're going to use it to describe a figure that increases or decreases in size. All right, so scale factor is a multiplication factor applied to all pre-image points as a distance from a point of dilation to create a product, which is the distance from the point of dilation to all the image points. So this value here is a variable. We're going to call it d. And so we have our pre-image, which is the blue rectangle, and a point A, and we're going to dilate that by a scale factor of +2. So just a note here, we need to separate out the sign of the scale factor and the value, absolute value of the scale factor. We'll come back to talking about sign in just a moment because we can't have a scale factor that is negative. And so in this case, we're starting from the point or the center of dilation, and we're going to expand. If this, let's say, is point B, then this line of dilation goes through both points, and the distance from the image point here on the red rectangle to the center of dilation is now going to be twice that of the distance from the pre-image point on the blue rectangle to the center of the point of dilation. So we say the scale factor is 2. So we're increasing the size of the image from the pre-image by a factor of 2 from the center of dilation. All right, so let's talk about lines of dilation. Line of dilation is going to start at the center of dilation, and it's going to go through both the pre-image and the image point. So all those points the line will go through. So you can see that the origin of this line, or the line, will go through the center of dilation. And by the way, the center of dilation, point of dilation, does not have to be the origin. As an introduction, we're just using the center of dilation as the origin. But you'll see we'll move on to talk about centers of dilation that are not the origin. Right, so also the lines of dilation are typically going to have slopes that are going to be different, right, as I connect the pre-image and the image points. All right, so they originate, or go through the center of dilation, and the slopes will generally have different values. Okay, all right, so let's move on. Now let's talk about negative scale factors, and unfortunately I need to do a little bit of work in drawing my lines properly. So this should be a line here from B to B prime, should be a straight line through the center of dilation, which is the origin. And so this negative scale factor here in this case just means that the line of dilation from the center of dilation is going to move in the opposite direction from the preimage. So in this case, we have the line of dilation initially moving in the direction of the preimage. And when it's a negative scale factor, now we're going to move in the opposite direction. And this line, if we were to draw it, should intersect with B prime, and that would be the value. All right, so we separate the two values. Negative just means move in the opposite direction from the preimage, from the center of dilation to the image, from the preimage to the image, through this center of dilation. And then 1 just tells us the scale factor. So if the scale factor is 1, then the distance is going to be the same, and the object doesn't change. At least the size does not. So there are a couple things I want to show you. We can have a scale factor of that is negative, and we can also have a scale factor of 1. So this is how that plays out with a dilation. All right, so scale factor of 1/2. Now we have the larger rectangle here, and the smaller rectangle now is going to be the image. So pre-image to image, a scale factor of z to 2z here. So from the image to the pre-image gives us a scale factor of +1/2. It's in the direction of the original pre-image, so it's going to be a positive value. All right, so the rule would be, if you want to write a rule, 2 ways we can say it. We can say dilate 0.5 about the origin, 0, 0, or we can write it here as we have numerically x comma y in parentheses with the arrow 0.5x comma 0.5y. All right, so next step is to find the coordinates of the pre-image, pi, and the image, given the image pre-image, the center of dilation at the origin as scale factor. All right, so I want you to dilate +3 about the center of dilation. So all we're going to do is we're going to multiply each of the x, y values by 3, and it's very straightforward when the center of dilation is at the origin. Not so straightforward when it's not. Okay, so we've done that. 3, 6, 9, 18, 15, 3 are resultant image values. Let's do the same thing for a scale factor of +2. Okay, 6, 12, 2, 4, 10, 2, scale factor of 2. All right, so now I'm going to give you the pre-image points, and now I want you to find I'm going to give you the image points. I want you to find the pre-image points. Give it a center of dilation of the origin and a scale factor of +2. All right, so you can see that now we're going to have the values, right? Because we need to multiply these values by 2 in order to get the image points. So your answers are B, A, and C. Notice they're not B prime to A prime and C prime. Those are the values we have. 1/2, 3, 1/2, 1 1/2, 3, 0.5, 1, 2.5, and 1/2. Okay, now I want you to dilate -2 about the origin. I'm going to pause here while you do this classwork. All right, so you're going to get these answers, -2, -4 for A prime, and you can read the balance. I've also provided you with the distance from the image points to the center of dilation, just as a reference, because we know the scale factor is the distance from the center of dilation to the image divided by the center of dilation to the preimage. Right, and this is graphically what you're going to look at. I didn't have enough space in the prior slide to put these values in here. Okay, so we're going to move on. Of course, you can pause at any time. I know I'm going through this quickly with the understanding that you can pause if you need to write anything down. All right, so third, we're going to write a scale factor, write a rule, given a coordinate for both the pre-image, image, and any center of dilation. Okay, so here I have any center of dilation, -1, -2, and A is 1, 2, and A primed, image 7, 14, so we want to find the scale factor. All right, so now because we're multiplying both the distances for x and y, we only need to consider either x or y when we're evaluating what the scale factor is. So let me tell you what I mean. All right, so I'm going to take just the x values, the distance on the x coordinate from A primed to the center of dilation. So 7 here, 7 minus 1, leaves me with 8 units here along the horizontal axis, x-axis, to A primed. And that's going to be over the distance from A along the horizontal axis to the center of dilation just for x. So 1 minus a minus 1 is 2, and that's how I get my scale factor. So distance A, center of dilation is 2, A primed, now not the absolute distance, just on the horizontal plane. or horizontal axis. 7 to center of dilation is going to be 8, and my scale factor is 4, so dilate 4 about -1, -2. All right, so now I want you to come up with a set of rules, and I'm going to give them to you quickly, using all these variables, right? So we have, if we go back to what we were doing here, we were using this, we had 3 points, center of dilation and dilating. Center of dilation, and then we had the coordinates for the pre-image, and then the coordinates for the image and the scale factor. So those 7 variables, center of dilation 2, pre-image 2, image 2, and the scale factor would be 1. That's 7 different variables we're working with. I want you to see if you can write some equations for this, and I'm going to show you what I've generated. All right, so these are some formulas that I've used. So A primed, the x value for A prime minus center of dilation, the x value for center of dilation, over A sub x, so the x value for the pre-image minus center of dilation is equal to your scale factor. You can evaluate this. And then I'm going to rewrite these. So I'm just multiplying the denominator by the scale factor to rewrite these algebraically. You can list them this way. And you can also say, because we know the scale factor is equal to itself, and these values for x and y are the same. Notice these are x, these are y. So different formulas you can work with. And then we're going to go back to our original problem here that we had. The center of dilation wasn't the origin. And we're going to evaluate this using here the formulas that we put in. And you can analyze this. So you put in the values that you know, right? We're looking for the scale factor. So A primed x minus center of dilation x over AX minus center of dilation x gives us a scale factor here, and the scale factor was 4. All right, so next we're going to use those formulas. We're going to find the coordinates for any pre-image image for any center of dilation, not at the origin, given its image, pre-image, and the scale factor. All right, so what does that mean? All right, so here's a scale factor -2, and I want you to find the image based on the pre-image 1, 2. Okay, so we're going to use our equation here, A primed x minus center of dilation x is equal to scale factor, AX minus center of dilation x. So we don't know what A primed is. So A primed x minus 2, we know that center of dilation is is 2 here, so A minus 2, center of dilation for x is 2, is equal to -2 the scale factor times A sub x, which we know 1 minus center of dilation for x, which is 2. And we can see that A primed x is going to end up being 4 if we work on this algebraically. Okay, so now we need to find the value for y. Same thing. A primed y minus center of dilation y is equal to -2 times A y minus center of dilation y. We're going to substitute the values in here to find A primed y. That's what we're looking for. And we end up with -7. So again, I went through this pretty quickly. Please pause to review these values and the relationship to the formula that I gave to you. I'm going to move on. Okay, so finally find the center of dilation given the scale factor and 1 coordinate each for both the image and pre-image. All right, so here we have A primed. We want to find, and the scale factor of 1/3, we want to find the center of dilation. So going back to our formula here, A primed x minus center of dilation x over AX minus center of dilation x is equal to the scale factor. We're going to fill in the values that we know and identify the values that we don't know. So we don't know the center of dilation, so we need to find those values for x and y. So we substitute values in here, and for the scale factor we find that x is equal to 1, and we're going to do the same thing for y. And again, I'm working through this pretty quickly. Same thing for y here, evaluating, substituting values that we know, and then solving for what we don't. Y is equal to 4, and we have our center of dilation xy. Okay, last we're going to find the center of dilation, the scale factor, given 2 sets of dilated points. All right, so I have 2 sets of dilated points here. Okay, actually we're running out of time here for the video. I need to cap it at 15 minutes, and it's going to take a little bit longer to cover this topic, so we'll create another video to find the scale factor and the center of dilation based on a set of 2 dilated points. All right, that's it for this portion of transformations and dilations. Join us next time when we talk about the subject, scale factor and center of dilation from 2 sets of points in the next edition of Math.